Hi, this is Mrs. Nickel. Today I want to help walk you through how to set up your germination lab. Now, the germination lab is one of my favorite activities to do in Science 7 because germination is something that typically happens underground and we don't get to see what's happening. But here's an experiment where you can actually watch the process, see it happening essentially before your very eyes. And I know that it's something that I personally do the lab every year when I assign it to students. So I actually love to do it myself. I bring it home. The kids and I watch eagerly every day to see the changes that are happening. And this is just a really great way for you to understand kind of the sequence of germination, the order of steps that it happens in, and to actually be able to see the process yourself. So the first thing you're going to have to do before you even set up and gather your supplies for your lab is that you need to set up your observation page in your visual journal. So now mine is actually filled in from some information from when I did the lab last year, but you can see that at the top I'm going to need to have some kind of a title. So I did Germination Lab. I showed the first kind of leaf coming out of the top of the word germination. So be creative, use your visual note-taking strategies, and make a nice creative title for your observation page. Now you notice that I have set up boxes on my page that are all the same size. So they should be at least 6 centimeters by 6 centimeters. You can make them bigger than that, but I would suggest no more than about 9 boxes on your page. You can make them larger if you want. I've seen some students set it up with kind of larger boxes down the side and room to make notes over on this side. So you can set it up however you want. I'm going to suggest it should take 2 or 3 of your visual journal pages to fill this in because you are going to be monitoring your experiment for about 14 days, possibly longer. So definitely save up at least 2 pages, and I would start by making 14 boxes that you're going to use for your observations, and you should leave some room that you could add more. Okay, so you need to set up these boxes. They should be the same size, and you want to make sure that you are drawing kind of the same size of things every day so you can compare them. So if you actually look here, I was actually able to draw my setup, so my baggie with seeds in it. You can draw the baggie in every single day, even for days that you haven't actually seen yet, because you know that that part of the lab is going to be the same. So the only thing that you'd have to draw different every day is just what does the seed look like? Does it now have an embryo root sticking out of it? Does it now have a stem coming out the top? Has the leaf unfurled or is the leaf still closed up? How many roots are there? So those things will change every day, but the setup itself, the actual bag with the seeds in it, will be the same. So you could draw that out and have that all prepped so that every day when you're doing your observations, it actually goes very quickly. Okay. The other thing I would suggest is having a little legend up here in the top. So instead of every day writing down apple seed or writing down pumpkin seed, you could just have a little legend that says, you know, A is for apple, P is for pumpkin, and then when I actually label my diagram, I can just say, you know, the length, and I could even say the length is L. So when I measure it, the length L of A is, you know, 4 centimeters or something like that. So I can use these abbreviations in my legend instead of having to write out the length of the apple seed is 4 centimeters. That's a very that will take up a lot of space on your page, and you don't want to do that. So make sure you take a look at the examples on D2L and see some of the ways that I showed my data without having too much information on the page. Now, the other thing I didn't do on here, because when we do this in the classroom, we can actually measure the amount of water that we're putting in. But in this case, you guys might not have that available to you at home. So what we're going to do is any day that you add water, you will just draw a little water droplet in the top corner. And you can put that in your legend as well. that a little water droplet in the top corner just says that you've added water for that day. We're not going to worry about the measurements this time, about how much we are adding to it, but at least we want to make a record of things that we had to add throughout the experiment. And this is just part of keeping good records, and as you get further on in experiments, you'll have to control some of your factors more, but for this experiment, we just want you to practice taking good observations, okay? So make sure you have your observation tables all set up first. That is your first part of the process, okay? Now, the next thing that you need to do is you need to gather up your supplies. So here's what you're going to need for this lab. You're going to need to have a paper towel. You're going to need to have a sandwich baggie. You're going to need to have a spoon and some water. And you're going to need to have 2 different kinds of seeds. So I've used lots of different seeds in the past. If you have bags of dried beans in your cupboard, or if you have seeds that you have had from previous years gardening in the garage, you can take from there. So I've used pea seeds, dried lima beans, dried navy beans. For this year, I'm going to try something different. Last year I tried a pumpkin seed, so I'm going to do that again. And I'm also going to try an apple seed. So this just came out of one of my apples. My son likes to eat apples and leave apple seeds all over the place. So I just picked one up that I found, and I'm going to try and see if I can grow it. It would also help if you have a stapler. I'm not quite sure what you would use as a replacement if you don't have a stapler at home. But when I get to that part of the process, and if you don't have a stapler, just think about what you could do instead. And then you're going to need some tape at the end in order to attach this to a vertical surface. Okay, so here's how you're going to set up your lab. You're going to take your paper towel, and this is one of those select a size paper towels. So if you have a select a size, that's great, because you just need one page or one little sheet of it. If it's bigger, you may have to fold it more. But I find with just this one size, if you fold it exactly into half, okay, it is going to fit just perfectly on the inside of your sandwich bag. So you're going to put this in to your sandwich bag, okay, so that you can see that it fits. You can close up the top if you want to, and we're going to talk about that a little later, but it should just fit nicely. And you do want the paper towel to be touching the bottom of the bag, so that if there is water in the bag, it won't just pool at the bottom, it will actually get sucked up into the paper towel. Okay, so now here's where your stapler comes in. Not halfway through the bag, but a little bit higher up. You want to take your stapler and you're going to staple through the bag, okay, in 2 places. So I'm just going to staple through here, okay, and show you what I did. So what this is it's providing a little shelf for your seed to sit on inside your experiment bag. And the reason that's important is because if the seed just falls down to the bottom, it's very, very difficult to see how it's going to grow. Because if it's laying on the bottom, the stem will grow up, but the roots aren't quite sure where to go because they can't really go down. If you put your seed here, okay, in your experiment, you're actually going to be able to watch how the roots move or how the roots grow in a certain direction, how the stem grows in a certain direction. So it's really important that you have something in your bag that will allow your seed to kind of sit in the same place and not fall down. So if you don't have a staple, you're going to have to figure out something else that would serve the same purpose. If you are really stuck, send me an email and we'll see if we can come up with something together. Okay. So then the next thing that you do is you're going to take your seed and you're going to put it inside your bag right on top of your staple. Okay. So I've got my pumpkin sitting on top of my staple. It doesn't have to be touching. It's just that the staple is using it to hold it in place so it doesn't fall to the bottom of the bag. And then I've put my apple seed in. Okay, so you can see that both of my seeds are now sitting in my bag. Now, we can close the bag most of the way. We don't need to close it all of the way. We can still leave some air coming in at one end. We do want the plant to still have access to oxygen once it starts growing, but the biggest thing why we don't want to leave it all the way open is because then too much of the water can evaporate. So we want to have the bag mostly closed, but not all the way closed. And later on in your experiment, when the stem starts growing up, if it gets to the top of the bag, you actually will need to open the bag all the way up so that the stem can continue to grow out without getting stuck. Okay? So then the last kind of step you need to do is to take a spoonful of water, okay, and you are going to pour it into your bag over the paper towel. And we want to get the paper towel wet, okay? So you can see when I added in the water that it started to spread through the paper towel. I can maybe add one more spoon there. So it doesn't have to get the whole paper towel wet, but you should make sure that the paper towel is wet right behind where the seeds are, okay? If you add water and you see that there's water pooling in the bottom of the bag, that's too much water. Your seeds will actually probably mold if you do that. So please make sure that you don't have too much water at the bottom. You just want to have the paper towel wet enough that the seeds will be able to absorb water and start the germination process. Okay, so we can close it mostly so that we don't get too much evaporation. And the very last thing that we need to do is take some tape, or if you have a cork board at home, you could always use a tack, and you could set it up that way. But what we need to do with our experiment is we need to attach it to a vertical surface. So you can just make sure that you tape it in a way that it's not going to fall down. You don't want to tape it on the top, because if you tape it on the top, then when the stem starts to grow, you might have problems. So if you just tape it on the side so that it's sitting flat on a vertical surface, then your experiment is all set up. Okay? Now, I'm going to tell you in a few minutes that you could actually set up 2 experiments, but the next stage I want to walk you through first is now you need to draw what you see. So this is your first day of your germination experiment. So in your visual journal, in your very first box, you need to draw up your germination setup. So you see how I drew the bag, I drew my staples, and then I drew the 2 seeds sitting on top, okay? Now, the one thing that I haven't done yet is I need to take a ruler and I need to measure the length of my seeds. And that's something you're gonna have to measure your plant or your seeds every single day of your experiment. Now, when you take your ruler, you're going to measure from one tip of the seed to the other tip of the seed, okay? Be as accurate as possible. Now, for the first couple days, it's really important that you do measure every day, because you might look at your seed and think that nothing is happening. But if you measure, you'll notice that for the first couple days, before anything visible happens, the seed actually starts to swell. It will be absorbing the water, taking the water in, and allowing the root embryo, or the embryo root, the radicle, to start forming and start getting ready to pop out of the seed coat. And so it's really important every day that you are taking a measurement. However you take the measurement of the seed, the next day take it the same way. So go from tip to tip, and I'll do the same thing for my apple. I'll measure from tip to tip with my with a ruler that I have at home. If you don't have a ruler at home, you can always print a paper one off the internet and just use that. That will be close enough, okay? And then so you're gonna put your measurements in your observation box. So the length of my apple seed is how much, the length of my pumpkin seed is how much, and I will record those values there, okay? Now, at the beginning, you're just gonna be taking the length of your seed. As your experiment goes on, you're gonna start seeing the root pop out. Now, the root will not necessarily be straight, and so you may have to measure the curved root, as one section, measure what's left of your seed or your seed coat still, and then add those together so that the length might be 2.5 centimeters plus 1.2 centimeters. So then your total length would be 3.7 centimeters or whatever it is. Now, as you start getting more and more roots, we just want to keep it simple. You don't have to measure all of the roots, just always measure your longest root. Okay, and then once it starts growing a stem, just measure the longest part of the stem. If it does pop out a leaf, you could also measure the length of the leaf. So really, we're just trying to get an idea of how much the plant is growing every day and of kind of the size that it gets over a certain amount of time. Okay, now you are going to be watching this experiment for at least 14 days. Once your seed actually sends out its root, sends out its stem, the stem goes up and the first leaf actually opens up so that it can start to perform photosynthesis, then you can stop recording for that seed. So chances of them happening them getting to that point on the same day are not good. So for one seed, you may only have to measure it for 10 days. Another seed, you may have to measure for 16 or 18 days. It kind of depends. So your experiment should go probably a minimum of 14 days, but it kind of depends on what seeds you're doing. If you skip a day, if you forget to measure for one day, it's really important in your observations that you show that you missed a day. So my first measurement today, so if this was actually going to be my setup for today, I would say that it is May, I'm actually doing this a little bit early, but we'll say it's May 25th. I'm setting up my experiment. And then let's say on Tuesday, I forget to check. So then my next box is actually going to be May 27th, Wednesday, May 27th, because I missed a day. So no matter what, we want you to try not to miss days, but if you do, be honest about it in your observations. It's really important that you don't just make up a date or lie about it, because we need to be able to see that there was a gap between when you took those measurements. And it's just part of good habits for scientific record keeping that you always want to make sure your records are honest, even if you missed a day. Okay, now, what do plants need for germination? Okay, so we know that they need water, which is why you're going to have to check every day. And if your paper towel is getting too dried out, you should add some more water and put the little water symbol in your observation box for that day to show that you added more water. Let's see, it doesn't need to have sunlight at first. And that should actually make sense because where do we plant most seeds? Underground. They're not going to be getting a lot of daylight. But, so they don't need light for when the roots start to grow. But once the stem starts poking up and once that leaf starts to go above the ground and spread out towards the sun, the plant is getting ready to produce its own food and to actually do the process of photosynthesis. And in that case, light matters, okay? And light will be required for the plant to continue to grow. Now, the cotyledon is the food source inside the seed. And until the plant can start to produce its own food, it will rely on the cotyledon as its energy source, and it will break down the sugars that are stored in the cotyledon, and it will use those for growth. But there comes a point in time when the plant needs to start doing its own photosynthesis, or else it will just wilt and die. Okay, now, so here's if you want to do a little bit of an extension for this lab, you could actually set up 2 of these experiments. So instead of just setting up one bag, you can set up a second bag and set up one of them with exposure to light, set up another one of them inside a cupboard. Okay, so you can tape it on the vertical surface inside a cupboard. And then what you can do is actually monitor and observe them every single day. So check out, how does the one on the wall exposed to light do? How does the one inside the cupboard do? And what would your prediction be? What do you think? Are they going to grow at the same rate? Are they going to, is there going to be a point where they start to grow differently? When is that point going to be? Will there be any physical changes? Will the seeds be growing the same up to a certain point and then something strange will happen? Okay, I would encourage you, if you have some extra seeds, so if you have 2 of one kind of seed and 2 of another, do the second experiment. Put one in the cupboard and see what happens and compare your observations. One thing that we're also going to do starting next week is we're going to put a discussion board on D2L available so that you can go in and put some pictures of your germination lab. And if you want to show some pictures of here's what happened to my plant on the wall and here's what happened to my plant in the cupboard, put those pictures online in the discussion board and tell your fellow students what you're seeing with your germination experiment. So I'm really hoping that this will give you a great view of how a plant actually goes from being a seed to turning into a baby plant that starts to make and produce its own food by doing photosynthesis. So good luck with this. If you have any questions, make sure you reach out to your teachers and have fun with germination.